Hey everyone, welcome back to my channel. Today we are going to solve a medium question on LeetCode, max minimum index of a valid split. Let me read the problem statement. An element x of an integer array of length m is dominant if more than half of the elements of the array have value of x. Okay. Uh, is for a given array of size, let's say m, which is called dominant if the frequency of element is greater than half of the size, which can be further can be written as 2 times. We can write like this, right? This is point 1. You're given a 0 indexed integer array nums of length n with one dominant element. Okay. Second point is given array contains only one dominant element. Okay. We can split the nums at index I into two arrays, which is nothing but 0 to I and I plus 1 till n minus 1. But the split is only valid if this I should be 0 till I less than n minus 1, not less than or equal to. This is third point, we can say. Split if this 0 less than or equals to n minus 1, and both the splitted arrays have the same dominant element. This is one more point. Okay. Where here now I denote the subarray starting index I ending at j, both index being inclusive. Particularly if I j less than I denotes an empty subarray. Okay. Based on this condition, we have to return the minimum index of a valid split. Let's say if there are multiple split, we have to return the minimum split. The first occurrence, like from the left, whatever the first index, if is a valid split, then based on these two conditions we can do that. And if there is no such split, we can return -1. In valid case, return -1. So these are the 4 points. Array contains only one dominant element, and dominant element is defined as the frequency of the element occurs more than half of the size. We can rewrite this as 2 times frequency of element of the size, right? Since the array contain only one dominant element, based on the second point, let's say if we make a split at some position in the array, let's say we made a split here, and since the array contain only one dominant element, if we know the frequency, the maximum frequency in this array, and if we know the maximum frequency in this array of the same element, then check the condition of this one, then we can say that is a we can say that is a dominant element, which is a valid one, and we can return this position I. So this I can be start from 0 till n minus 2, because one element should be one, then the second half should contain at least one element. So and this will have ending at I will have the one split and remaining of so how we can calculate a frequency here. Let's say if we calculate frequency of entire array and we we do a line sweep from left to right. Let's say for the first element I till we may then we will decrease one element from the first map and update on frequency of this element in a different map and check the frequency of this element, and it and if it satisfies the both like this condition, then that is a dominant element, and we got a since we are traversing from the minimum element to minimum index to the maximum index, we can return that index directly, and we can if we don't find if we don't satisfy that condition, we keep doing like removing one element from one map and adding one frequency in the another map and check the frequencies, multiplying with the 2 and the size. We can get the size easily. If we are at I, this will be I plus 1 will give the size of this array, and this size can be calculated by size minus I minus 1 will give the remaining size of the array, and we got the frequency from the two maps. uh, so this is the approach. Let's try to code this up quickly. So we need, let's say we maintain left and right maps, new hash map. uh, I've created two hash maps, and we will compute uh, uh, we will first calculate all the elements in the given array in the right dot put num right dot get our default. The key is num and the default value is 0. So this will calculate the frequency.
Calculated the frequency of entire array. We will make splits of the mental language, which is not fine. So we will do that. Remove element. Okay. We will decrease the frequency by one, and we will increase the frequency. If we are inserting at the first time to handle that, we will use the auto default. Okay. Now we see since array contains only one dominant element, we try to check the frequency of the current element on the both sides. So left of get of num times 2 is greater than based on this make less 1, and we calculate the frequency on the right and 2 greater than We will declare a variables and size minus I minus 1 will give the side of the right side height. If so, we'll directly return minus 1. If not, we will return, sorry, this we will return directly index. If we don't find any split, uh, we return minus 1. Uh, for every element, I think get num and with the decrement in it. Um, Here the frequency is 1. Um, it will be 1, it will be 2 and 0 greater than 5, which is false. In the next iteration, no, should be 1, sorry. Mm, seriously, okay. We have to leave one element. So, so this is, let's try to analyze time and space complexity. Uh, we are using two hash maps. Uh, this side, let's say, n is the size of the other. At most, we will be having an element in the each hash map. And that's it for the space. So big of n activities to n. In big of times, it will be n. And we are traversing each element. Like this will take big of n. And we are doing some constant operation. And this will also run n time. And these are all constant operation. So overall time complexity will be big of n. Let's try to submit this solution. Accepted. If you like this video, please like, share, and subscribe to my channel. And we'll see you in the next video. Bye.